I'm Mr. Sullivan.
And I'm Mr. Hodges.
And we're here to talk to you today a little bit about what is science.
You know, Mr. Sullivan, what is science? Is it sitting in the classroom, listening to lecture? Is it going out in the field and doing some research? Even in the lab doing some research? What exactly is science?
All great questions, Mr. Hodges. What we've done is we've compiled for you a smattering of some of the great minds here at McLaughlin Research Institute to try to tackle these nebulous concepts. So sit back and enjoy.
I think my gut reaction is the study of the electron, but that's really chemistry because I'm a chemistry nerd. If you asked for a broader definition of science, I think for a large part it's man's attempt to control his environment, because I think a lot of the times as humans we kind of look around and realize how little we are, and we really are curious, and so those two factors meet, and then you get science, all of it.
That's a question that we always ask our Foundations of Science students, but it's not like the easiest question to answer, I don't think. A lot of times they'll say it's biology or chemistry or physics or a class they take in high school, but when you put all that together, a lot of times we define it as just everything. But working at McLaughlin, I think I found that it's not just everything, some vague description, but it's also the process. So we have all these questions about the world around us, and science is what gives us the tools in order to answer those questions. So science is the process of everything.
I think science is really a way of thinking. I think a lot of times what we do is we like to classify science by a specific category, but I think a better answer for me is science is kind of a process of thinking. It's a way of thinking. It's a way of kind of learning about the world around us, whether it be living things or chemical nature or anything in the environment. It's a process of finding out what that truth is.
Well, science is not a collection of facts. It's a process. It's a way of learning how the world works. And it's based on the assumption that there is an external truth out there, and on the assumption that you can figure out what's going on in the natural world. So science is, by nature, change-seeking. It's not a constant. So things that you may have learned at one time may or may not be true, and it's self-correcting. So I guess that's probably one of the most important things that it is, that science is self-correcting. It's also anti-authoritarian, because what your teachers tell you, you say, wait a minute, is that true or isn't it true? And you can design experiments to test your ideas. So it's also sort of it has a sense of equality. Everybody's ideas initially have a fair shot. If you're willing to test them and to propose hypotheses, they have a fair shot. But in the end, not all ideas are equal. Some people are right and some people are wrong. So in that sense, it's like a meritocracy. So some people are better at getting the answers than others. But I think the biggest thing is that it's a process, and you have to be willing to accept the fact that you're wrong. So fundamentalism and science don't mix. So you always have to question authority, question what's going on in the world, and try and think and critically evaluate things.
Well, we've got a series of interviews on kind of what science is, and we got some kind of idea what it is. I've got Dr. Richard Bennett here from McLaughlin Research Institute. Richard, how do you use science in the lab?
Science in the lab really is the application of the scientific method, bringing in the aspects of making observations, and then formulating a hypothesis, and then testing that hypothesis based on some basic criteria. So we want to make observations of things that are measurable, first of all. We look at things that you can actually quantitate or quantify. Once you have made these observations, then you can formulate some conclusions, draw some conclusions, formulate a hypothesis, make some predictions about that, and then go ahead and test those predictions with, again, measurable scientific experiments and experimentations. And this isn't a hard and fast rule. This is really just kind of a guideline for the way in which we really approach a problem. And this can be any problem, not just in the science laboratory, but it can be any problem that you approach anywhere in your life. You see a problem, you make some observations about it, make some predictions, and then formulate some ways that you can test those predictions to see whether or not the hypothesis was correct or not.
I know the burning question is, every time you apply science in the lab, are you correct? Do you find the right answer every time?
No, absolutely not. In fact, most of the time we prove that our hypothesis was wrong. And we go back, revise that hypothesis, make changes, and try it again. And that's the way science moves forward, is you make a hypothesis, test it, move forward.
So I think from this set of interviews, Mr. Sullivan, we got a pretty good idea of what science is. It's not so much what topic you may be studying in your class, like biology, chemistry, or physics, or some kind of lab research, or even a defined set of steps to work you through something, as it is kind of a guideline as to, here's a way you can solve a complex problem that you may be encountering in everyday life.
Indeed. Well said, Mr. Hodges. And I think the only question that remains is, what is science to you?